Alright, hello, my name is Brandon McMillan and I am a student at the University of Central Florida, and I'll be giving a presentation on a quick guide to Linux and how to get used to some of the basics. This presentation is being created for the course Computer Forensics 2, CNT 6418, in the spring 2017 semester. So without further ado, let's go ahead and get right into things. So, first thing we want to do is note what we'll be covering in this presentation. First, we're going to go ahead and get a little mental preparation ready for what we're going to be going through in Linux and how the system actually thinks. Then we're going to go ahead and take a look at how permissions work within the system and check out some of the various permission levels and how those are set, as well as reviewing the various file types in Linux. Then we're going to go ahead and we're going to look at the file system structure, get a nice overview of it, see some visuals, and then we're going to review the file system contents and see what each of the subdirectories is actually for. And then we'll do a quick overview of some of the basic commands that are available to you from Linux and how they compare to our standard Windows DOS commands. And then I'll be going through a quick demo of using some of these basic commands. So, first things first, let's get our mindset correct. So, when using Linux, it's important to note that pretty much everything is a file. A directory that contains other files, those are considered files as well. It's just a folder, but it's a folder that's treated as a type of file, which is known as a directory, and it's just a file which contains the names of other files. Input and output devices are also files. Programs, services, texts, images, anything and everything in Linux will be considered a file as far as the system is concerned. So the only thing that would not be a file would be a process. And a nice naming convention that Linux provides is that hidden files will start with a period. So if you're browsing through Linux file directories and then you run into a file whose name is prepended with a period, but then you go and look for that same file in the GUI, you will not be able to find it. You may not be able to find it because that file will be hidden. So you'll have to have some proper permissions set in order to see that file. Alright, now let's go into some of the permissions that are available to us in Linux and actually get a better understanding of what it is that Linux does. So there are 3 different levels of permissions in Linux: read, write, and execute. Linux sets these permissions on 3 separate levels: the group, the user, and the owner. Now these 3 separate levels, they are in a hierarchy, so the owner's permissions supersede the group's permissions, which supersedes the user's permissions. So let's just take a quick look at the structure of how these permissions are set for each file. It's stored in an octet, which we have a table listing all of the possible combinations of that octet. And you see from listing the decimal values 0 through 7, we can capture every possible combination for this octet. And here's a quick table to show that. We have a file which has no permissions, which would have a decimal value of 0. Well, you'll see this dash 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 set on the user, group, and owner levels. And then down here, for the decimal value 1, you'll see if the owner can only execute, then you'll see a dash dash X. In the case where you can only write to this file, you'll see a dash W dash, which will have a decimal value of 2. We have the write and execute permissions, which will have a decimal value of 3. If you can only read this file, then it will have a decimal value of 4, and so on for the values 5, 6, and 7 for the permissions to read and execute, read and write, or read, write, and execute. Now, each of these octets is set for the 3 levels of permissions, whether it be an other user, a specific group, or the owner or the creator of the file. And we can go into some examples to actually review and see what this looks like in the actual Linux terminal during our demo. So there are quite a number of file types in Linux, as you can imagine, since everything in this system will be considered a file. So some of the nomenclature used would be for a regular file, there will be no symbol. We'll simply have a hyphen there. If the file is a directory, you will see the letter D placed in the file type column. If it's a link, you'll see an L. Now, all a link does is it makes a certain file visible to the user from one location exterior to the file's actual location. So you can think of this as a shortcut or a quick little link to send you from one area of the file system to another. There are special files, which will be marked with a C, socket files, which will be marked with an S, and we won't be going through any of these special, more advanced files, but it's good to know that they exist. There is a named pipe file, which will be marked with a P, and the block device, which will be marked with a B. And we'll see examples of most of these in our demo, so no need to fret. So let's take a quick look at the file system layout. You'll see on this visual to the right, it looks like a pretty intimidating hierarchy and a pretty big graph, but we can tackle this pretty easily, and we'll go through it slowly so that we can get a good understanding of what everything is doing. So the most important thing to note is that everything resides under the root directory. Now, this root directory is simply denoted with a /. So if you were to go into the Linux terminal and then navigate up to the top layer, as high as you can go till there are no more parent directories, you would simply see that your current location is named as /. Now, from this area, this top layer, the root, there are a number of standard folders which are available, directories if you will, and we'll go through what each of these subdirectories is used for. But some that you might want to take note of are the bin directory, the boot directory, which would be used for booting the device, which is very important not to mess that up. But this home directory, we'll see, is something similar to what we're used to seeing in Windows machines where we have users. So from this home directory, you will see a number of user profiles named Rick, Anna, Emmy, and Bob. So these are the various user profiles associated with this machine. There are also a number of other subdirectories which may seem a little foreign to us, such as the mount directory, which is Linux's way of storing input-output devices on the file system. And then we can come down here and we can see the user file, which will have some user information and variables, and there are a number of other directories. So let's go into these directories, and you're probably thinking, what do all these directories do? Let's define that. So here are all the directories, and just as a quick overview, the bin directory will mostly just have some common programs that are used by the system admin, and the users. The boot naturally would have the startup files for the kernel, and just really core data for booting the system up, the bootloader. The dev will contain references to all the CPU peripherals. So this is how we will use our special files in order to connect everything in the file system. The most important system configuration files will actually reside within this etc subdirectory, and it's pretty comparable to the control panel in Windows. There's also the home directories, which we discussed earlier, which has the common users where we have user profiles shown. There are I'm going to go ahead and skip the initrd, which it's used for booting, and that's just some information. It's important and pertinent to the running of the file system, but it only exists on some distributions of Linux. The lib or library directory, it contains files for various programs used by the system or the user. We have a lost and found directory, where files that were saved during a failure, so if the system needs to reboot in an emergency situation, any files that need to be stored there temporarily will be stored in the lost and found subdirectory. Miscellaneous is used, surprisingly, for miscellaneous purposes. The mount is where we will have our external file systems like a CD-ROM, a DVD driver, or just anything external to the file system. The net directory is where we'll have remote file systems. That's how we'll mount those. The opt is where we'll have extra software that isn't necessarily part of the original file system, but probably third-party software, things of that nature. We have the proc subdirectory, which it's mostly used for virtual file systems, so we won't really go into that. The root directory is the administrative user's home directory, which is just, it's not to be confused with the actual root, just a simple // The /root directory is a directory for the root user. So the same way that users Emmy and friends had their own subdirectory under home / their name, the root user will have his own subdirectory under /root. There is the sbin for programs used by the system and the system admin, a temp subdirectory for temporary use by the system. It is removed and cleaned out regularly, so it's not a safe place to keep your work. There's the user USR subdirectory, where programs, libraries, documentation, and other information like that will be stored. There's the var subdirectory, which is used for storing variable files and temporary files. These files are things like logs, a mail queue, an image of a CD that you're actively burning. So because that information would be removed afterwards, we'll store it in the var folder so that it can be disposed of after the task is done. So now we've got a pretty good understanding of all the subdirectories that are available to us in Linux. Let's go ahead and look at some of the basic commands that we'll actually be using. Alright, so now that we have a fairly solid understanding of the structure of the file system and what these subdirectories are for, let's go ahead and look at some of these basic commands that are available to us in Linux. So when we first get into the terminal, one of the first things we'll want to know is where are we in that file system. So with the pwd command, we can have the terminal return to us our current directory's location. That's going to be useful for seeing where we actually are. Afterwards, we can use the ls command to list the directory contents. This will show us what other files are available from our current location. Now this ls command is nice because we can add certain arguments to it in order to get extra details for the files that are within the current directory. And we'll see that we'll see the file permissions, some of the file types that are available, and we'll get like a very good understanding of what the contents are. There is the uname command, which is quite useful because this Unix name is a more human understanding of what the command actually means. It will print out detailed information regarding the machine name, the operating system, and the kernel information that are being used by the current machine. So this will be useful for getting to know your machine and what requirements will be needed for it. So we'll need to have a means of navigating throughout the file system, and we can do so with the cd, the change directory command. We can use that to navigate up to the parent directory, whether or not we know the actual name of that directory, or we can navigate to anywhere in the file system if we do know the exact path of it. Next, we have the cp, the copy file command, which surprisingly will copy a file. You are to give it certain arguments, and then one argument would be the file to copy, and then the other argument would be the destination of that file. There is the move file, which will move a file from its current location into the desired location. Again, arguments that need to be given to the command. There will be the make dir command, which will, surprisingly, it'll make a directory at the specified location, and you can specify the name of that directory and a slew of other variables which are available as arguments to the command. So when using commands, we can also pipe our results. Now what this means is that suppose a command outputs text. We can either have that text show up on the console or the terminal shell, as it's known in Linux, or we can pipe that into a text file. And if we use this greater than sign or the vertical bar, that will have the results from the first command pipe its results into the second command, the second argument. And this may be a little confusing at first, but once seen in action, it's actually really simple. The sudo command is not exactly a basic command, but it's very good to know. It's more so for removing access restriction, and what that does is it elevates our current permission levels and allows us to do things that we normally wouldn't be able to with our provided permissions. The dd command is very useful for computer forensics because it allows the user to create a bit-for-bit copy of an input file, and by doing that we can store and keep that information from that input file digitally sound and say, alright, we have this current image of the file, and now we can go ahead and conduct our analysis on that file. This can be output to whatever location we desire, and it can actually also be used to recover a device from a given file image. Next we have the less command, which can be used to view a text file from the command prompt, which is very useful for when we're just looking through some of our large text files and we just have to see them really quick on the fly and we don't really need to use an outside external editor. The less command will fully suffice. We also have the grep command, which will allow us to search through text for a target string, and this command can be used across multiple files, which is quite powerful and it runs very quickly. So that would conclude this quick introduction to Linux. Here we have some references, and next let's go straight into the demo.